So this video I want you to differentiate between the coordinate form and also the vector form for the given point. Now let's say we have a point on a Cartesian plane. Now according to the concept behind the coordinate system or coordinate geometry, you should have to understand that a point in a Cartesian plane is denoted by the two paired values, that is x and comma y. So this is the coordinate form of a point. Now how do we express actually this particular point in terms of a vector? Now this one will be given as actually this one will be given in terms of a vector A is equal to x down y. So this notation shows that this has been expressed in terms of a vector, and this notation shows that this has been expressed in terms of the actually a coordinate. Let's say we have a point M. In this case, in terms of, let's say we have a point M on a Cartesian plane. And let's say, by the way, we should have a point M within the Cartesian plane that we have here. We should make use of that. Let's say this is the Cartesian plane. And assuming that we have a point M with coordinates, let's say 2, let's say 2. Now, in terms of a vector, that particular actually a point M will be given as a vector M, which is equal to 2 down 2. This is the vector notation, this is the coordinate notation. And how should we present this on the Cartesian plane? In terms of the coordinate system, in terms of the coordinate or geometry, a point M will be given as 2, 2, which is basically this point. We'll have it as the point M, that is 2, 2. So now how about in terms of the vector? How should we have the point M in terms of the vector on a Cartesian plane? Strumor, this is the point A. This is the point of interest. But what will happen is that we're going to come up with the line drawn from the origin to that particular point, having it this way. So now arrowhead shows that this is a vector. And that this is the vector that is to be expressed as, we have it as 2 down 2. Rather should be given as this. So it will be expressed as this. So now have it as, this is the vector that is 2, 2. So this is how we present a vector on a Cartesian plane in that way. And let's say we have another, let's say a vector. So we have a vector N. I should say we should have it as, let's say, a point N that is given as 1, 2. Let's say this is the case. Now this point on the Cartesian plane will be given as 1.2, actually 1, 2, that is given as at this point. So this is the point 1, 2. Now how should we have this in terms of the vector? So in terms of the vector, then we'll have to draw the straight line from the origin to that particular point and show the arrow. The arrow itself shows that this has been expressed in terms of the vector. You should know that. But as to express it without the use of the Cartesian plane, then we'll have the vector N that will be given as, that will be now been given as, that is 1 down 2. We'll have that understand. By the way, we should have to express N as this. we'll just have to show the coordinates here, but n will be expressed as the vector in that case. So the side will be, so now as you can see, for this particular vector, this is the x value and this is the y value, and what it corresponds is this. Let's consider this kind of a case. Let's consider this kind of a case. Now let's say we have a vector p that is given as, let's say, 3 down, let's say 2. Let's say this is the case. Now as you can see on the Cartesian plane, the vector will be having as 3 down 2, that is given as this point. So which means we'll draw the straight line from the origin to that point. So what it means is that this is the x value and this is the y value. Now the vector can be expressed as the components. So this is the x component of the vector, that is given as 3, and this is the y component of the vector, that is given as 2. And as the information itself depicts. So at the end of the day, we may have an interest to have the magnitude of the vector, or how long a particular vector is. So now in order to have the magnitude of the vector, we use this method. Actually, we use this formula. So the magnitude of the vector p, that is the symbol for magnitude, or we call it as the modulus or absolute value. That will be given as the square root of x squared plus y squared. We use the Pythagoras theorem because this is more or less like hypotenuse. So this is the formula that you use to have the magnitude of the vector in that case. So which means the vector p will be given as, what is the x? You have it. Now what is the x? X is given as up to the 3. We'll have it as 3 to the power 2, that is given as 9 plus. Now we have y, that is 2. To the power 2 we have it as 4. So which means the magnitude is given as square root of should be 3. So that is the magnitude of the vector. You should know. Let's say we have the vector O with after, let's say, given as -2 down, let's say 4. Now what is the magnitude of this vector? So principle remains the same. We'll have x squared plus y squared. In this case, what is the x? We'll have it as up to the -2 to the power 2, that is plus 4 to the power 2. And what is the up to -2 to the power 2? We have it as 4. Have a square root of 4 and a plus 16. So in this case, we'll have the square root of 20 as the magnitude of the vector up to the O. So that is the principle behind that. And let's say we have the vector m that is given as, let's say, -5 down -6 in this way. Now what is the magnitude of this vector? So which means we have it as x squared plus y squared, that is the same as, then we have to substitute what is x, -5 to the power 2 plus -6 to the power 2. So you'll be able to have that in that way. And also try to have the magnitude of the following vectors. Let's say I have the vector n, that is 0.2. And also try to have this. Let's say we have a vector p that is given as, let's say, 2 down 20. What is the magnitude? You should have that. And also think about this one as well. Let's say we have the two vectors. Let's say we have the vector m that is given as, let's say, a w plus 2 down 1, and we have the vector n that is giving us 1 down, let's say 5. Now given that these two vectors are actually parallel, find the magnitude of the vector actually m. So try that one as well and see how best you can make it up. And also try to have this one as well. Let's say we have the vector s that is -5 down -30. What is the magnitude of this vector? So that's how you should have to understand about the vector notation as well as the actually a coordinate notation for the given point, and also the magnitude of the vector. Thank you.